Hello there and welcome to Lower 6th Further Maths. This is a January mock exam revision sheet 5, and here we're working on question 2, a roots of polynomials question. So, with a roots of polynomials question, if you've got a complex number that's a root of a polynomial with real coefficients, you can immediately infer from there that the complex conjugate is also a root of this polynomial. Now this stems from the quadratic formula. Remember, in the quadratic formula you've got a plus or a minus root something. Now that plus or minus is effectively what's happening here. We've got two solutions to this quadratic that will divide this quartic, and one is the plus solution, one is the minus solution. Okay, so from here what we're going to do is we're going to work our way backwards to work out what that quadratic will have been. And what we're going to use is the opposite of completing the square. We'll then divide that quadratic by this quartic and then hopefully get another quadratic that we can solve. So what we need to do first is take away the 2 onto the other side and then square both sides. Now on the right hand side we've got two things we need to square. We've got 3i that we need to square, and that will give us a minus 9, the negative from the I squared and the 9 from the 3 squared. And minus 3i squared, but seeing as this is a double negative here, the I squared will give us a third negative, so that would be a triple negative and will also give us minus 9. So expanding this, we get x squared minus 4x plus 13 equals 0. So this is a quadratic that should hopefully divide this quartic equation. Now let's see if it does that. So I'm going to use the box method for this algebraic division, and I'm going to need a box that roughly looks like this. Now all of these quartic elements here are going to be appearing inside the cells of this box, and I'm going to be multiplying the values that appear on the outside of the box. Now I'm dividing by x squared minus 4x plus 13 here, and this is effectively short algebraic division inside this box. So the first term I need is an x to the 4. So the first term I put in here is x to the 4. And to get this, I need an x squared. So x squared times x squared gives me x to the 4. And then what are the other values that will be created from this expansion here? So it'll be minus 4x cubed and plus 13x squared. The next value I need to look at is the plus 2x cubed. At the moment I've got minus 4x cubed, so I'm going to need to add on 6x cubed next. And to do this, I need a plus 6x in that top middle cell there. So expanding the brackets, I'm going to get minus 24x squared here, and I'm going to get plus 65, add another 30, plus 78x. Okay. The next thing I need to do is look at the squared term, the x squared. Now at the moment I've got minus 11x squared, so I need to plus on 10 more x squareds so that I get a minus x squared on its own. And to do this I'm going to need a plus 10 here, I'm going to need minus 40x here, and I'm going to need plus 130 here. And hopefully these other two values here and here add up. So 78x minus 40x, that's plus 38x, and 130, that's what I've got there. Perfect. So what we can say here is x to the 4 plus, and this quartic equation is equal to x squared minus 4x plus 13 times by x squared plus 6x plus 10. So I know the two solutions for this quadratic. I now need to work out the solutions for this quadratic. So let's use a similar method, completing the square. X plus 3 squared minus 9 plus the 10, so that will give me a plus 1 equals 0. So therefore x plus 3 squared will give me minus 1. And square root both sides here. X plus 3 is going to equal the square root of minus 1, that's I, plus or minus I. And then take away the 3, and you're going to get minus 3 plus or minus I. Okay, so there we are. Here are our four solutions then. We have x equals 2 plus 3i, 2 minus 3i. We also have minus 3 plus I, and minus 3 minus I. And that's what I would expect. I would expect four solutions to come out of a quartic equation. And you can always check this answer by going down to the, clicking the menu button, scrolling down to option number A. Click 4 for a degree of polynomial 4. Enter your coefficients in your quartic equation. Press enter and scroll through the solutions, and you should get every solution that we have here. Okay, so that's how you can always check your answers with these types of questions. That's 4 marks for that question.